Hi friends, welcome to the Cisco Packet Tracer tutorial where we are going to be discussing a few things, and we're going to be continuing with our case which we looked at earlier in the variable length subnet masking. So here we looked at the Parliament of Uganda and we said they had issues with their network, and the ICT committee recommended that we should have a full redesign, and they gave you as a network consultant to look at the network and be able to do the subnetting. So we did the subnetting, and we applied the variable length subnet masking, and we completed this table where we're able to create a subnet for the office of the speaker. We created another subnet for the government chief whip, the leader of opposition, and the clerk to parliament, and we're able to determine the subnet mask for all the subnets, the network address for all the subnets, and the range, the host range from the first valid to the last valid, and the broadcast addresses for all the 4 networks which were created. So sometimes when you have started working with Packet Tracer, they may ask you to use the tables provided. Sometimes they may ask you to derive the answers from the tables that you have, from the IP addressing table, which you have just created as a network engineer. So there are other details we shall look at later. For example, the router link, some of these they may be given to you, but the topology we want to build is a topology where we'll have at least two routers, router 1 and router 2, where they're connected directly over a crossover cable, and connected through a crossover cable. We'll have a router 1 handling all the traffic coming in from the office of the speaker, the speaker's chambers, and the government chief whip. Then we'll also have router 2, which will handle traffic that will be coming in from the leader of opposition and the office of the clerk. So we have 4 switches, 1 per subnet, and then we'll have at least 2 PCs representing, so we'll have a total of 8 PCs. So that's all you should remember, and we'll see how best. Sometimes they give you this table. You can just look at it and understand which network interface, which interface is connecting where, but basically that is the genesis of the network we want to implement in Packet Tracer, or the network we want to design in Packet Tracer. So to launch Packet Tracer, all you need to do is you need to come to the start menu and you search for Cisco Packet Tracer. The application looks like this. It has a magnifier with a message on it, and then you can click on open, and then click once and wait, and then it will load, and then you will get a program interface that looks something like this. All right, let me try and see if I can make my interface a bit bigger. Okay, so this is how the interface looks, and in this tutorial we are of course going to understand what is Packet Tracer, why do we need to use it, how to navigate Packet Tracer different interfaces, how to add different devices like routers, switches, and devices, how to identify the correct cable types depending on the type of connection you want to make, how do you configure the basic security settings on all the devices and routers, how do we assign IP addresses on a router interface, and how do we ensure that they are up and running, how do we configure PCs and IP addresses, subnet masks, different gateways, and do some connectivity tests between the different devices that are put together. So this is a scenario that we have discussed already of Parliament, which we want to come here and implement, and so we're going to go ahead and start right away. So Cisco Packet Tracer is a network simulation tool. It was developed by Cisco Systems, and it allows us to design and build and test computer networks on our computer without having the need to go to the shop and buy physical equipment like actual routers, switches, or cables, because these devices are actually expensive. So why do we use it in class and even for our exams? It's because real Cisco routers cost between about $500 to $5,000, even sometimes more each. And you can imagine real switches, patch panels, lab cables, they are expensive and always not available for every student to go and, get tests out different networks. So Packet Tracer gives us an opportunity, gives you all the students an opportunity to access a full virtual networking lab on your laptop completely for free. right? So what can we do in Packet Tracer? We can play with virtual routers, we can play with virtual switches, we can play with PCs, laptops, servers, and simulate a network design implementation in real life. So we can also connect them with virtual cables. We can type in real life Cisco commands into these virtual terminals, configure them, test whether your network works using the ping and traceroute commands, and you can even save your work so that you can open it later on and do different things. So sometimes Packet Tracer cannot simulate, of course, 100% of the real world situation, but at least for us at this level, we are able to simulate and ensure that the work works perfectly. Now, we are inside Packet Tracer, and we need to just understand the basic workspace where we can work from. Packet Tracer, you can just double click on any icon or just click on any icon, and then it will load and you'll see a window with several keys, and then a moment you get familiar. So we have the white space. This is the white large area space. Sometimes we call it the canvas. It is our virtual lab bench, like the table where you're going to put your devices. Yeah, you drag, drop, for example, router, drag, drop there, and then you continue working with your device. So that is the workspace where you put. So think of it like where you're working. The other part that we have is the device panel. Below here, we have the device panel, and we can choose from a catalog of different devices, and it's organized into network devices. From the network devices, we have end devices, we have components, connections, miscellaneous, etc, etc. And under even network devices, we have other subcategories like switches, routers, hubs, wireless devices, and so on and so forth. The cable connection panel here also has different connections. It's identified with the Lightning Thunderbolt, and we have different kinds of connections. Up here we have the toolbar, which contains tools for selecting, for example, selecting, deleting, inspecting, placing a note, shapes, other tools that are available. You will explore them later. Save, creating, opening, magnifying, demagnifying. Basically, it is a toolbar. And then once we click on any device which we have put there, we shall see another window which we call the device configuration window. So if you click on any device, you see a configuration window which pops up. You'll see it later on, and then you're able to configure our device in real time. At the bottom left, we can simulate our network either in real time or in simulation mode. So Packet Tracer uses these two modes. Real-time mode runs the network live, like the way it would work in a real-life environment. Simulation lets you to slow down the network so that you can watch how the different individual packets travel from the network from one device to another. But for most of this particular tutorial, and since we want to keep it very short, we are going to stick on real-time mode. Now, we are going to start designing our topology. Remember our parliament case that we need to draw. So we need to start by adding devices there. So I'm going to go to my network devices. I need to first add the first router. And I need to look. Sometimes they ask you to look for a particular device model. And when you look at my requirements now, it is requiring me to look for the router which is 2911. The 2911 router. So sometimes they may ask you to use 4331 depending on what requirements you have at hand. But for me, I'm going to use this, and to drag and drop, just click on it, drag it on your canvas, and it is there. And then I have added it there. It is there. And now I can see its default name. Sometimes it's router 0, sometimes it's router 1, depending on what you need to do. A quick reminder, you remember what a router is. A router is that device that connects different networks together. Now we have many subnets together. We have the speakers chambers, leaders of opposition, and for these networks to be able to communicate, we need to ensure that we have a layer 3 device, in this case, which is a router. It's going to read the destination IP of each data packet and decides where to direct or forward the path, the packets which are coming in. So without a router, these 4 different segments, subnets we have created, they are unable to communicate with each other. All right. That is the purpose of a router. So I'm going to repeat the same process, and I'm going to put there the second router and organize it in any way that I want. So I have my two routers there on my network. So I've added my second router, and then I need to add switches. So I'm going to, because switches are devices which connect multiple devices within the same network. So in the speakers chambers, I will have a switch which will be connecting all the computers in the speakers chambers. In the government chief whip's office, I will also have a switch which will be connecting all the devices from that particular network. So same network, it will learn the MAC addresses and then forward packets. Unlike the router, does connects different devices. Here the switch only forwards data within the same subnet. It is something important that you should take note of. So I'm going to go to my network devices area, look for the tab of switches, and then look for the particular switch that they want me to use. All that is per my network design. And as per my network design, I'm going to use 2960. So I'm going to drag. This will be for the speaker's office. And then I'm also going to go ahead and drag the same router, which is going to be at government chief whip's office, and then I'm going to drag another switch which is going to be in the lead of opposition, and lastly I'll have another switch for the clerk to parliament. And I think you can see how my network is starting to take shape and take design. So what I need to do, I can also go ahead and place the computers, right? As per my network design, they have told us they need at least 2 computers in each network. So I'm going to get my computers here and place them in that particular office where they are going to be, right? So I'll disorganize my network a bit. You can drag and drop. You see, it doesn't take long. As long as you have drawn your network, you have your network in mind already, and you know what you want to achieve at the end of the day, all right? So I have mine as well here. So, and I am putting and placing my devices there. So I have my last PC. So I have one more PC that I need to place, and I am good to go. So I've placed the pieces there. Now these pieces have default names, but when you look at my requirements has a particular name for all these devices. My routers are UG router 1, UG router 2. My PCs are going to be given different names depending on what I need to achieve. My routers as well, my switches are named speaker, government chip whips. I need to go ahead and also rename my devices basing on what I need to achieve at the end of the day. So for the router which is connecting the office of the speaker, I am going to go ahead and name it UGR1. So here to rename, you can either click on the label name, or I can click on the router. You click on it and then it will bring the configuration dialog box we talked about earlier. And then from here, I can navigate and look at the configuration tab. And under the configuration tab, there is the display name here. So I can change the display name here, and I said I want to name it UG-R1. I can also change the host name from here as well. So I have gone ahead and put in UG-R1. So the host name has been saved there as well. So I am going to repeat the same for this other router. So I can rename from here, and I just click on it here and I say UG-R2. All I said, I can click on it and then go into the configuration tab. Then the display name, I ensure I change it. I can also change the host name from there as well. So there are 2 ways you can do it. And then I'm going to repeat the same for the speaker switch, the switch for the government chief whip. So I'm going to come to the speaker switch, ensure that I click on it, come to config, display name. I can even change the host name from there. come to the switch for the government chief whip, click on it, come to config tab, and then go ahead and change the display name as well. So I have given it another name. So I can also come to the leader of opposition switch, ensure that I give it as per the instructions in my network design, give it, and ensure you type it exactly the way it is. If it is uppercase, use uppercase. If it is lowercase, use lowercase. It's good network practice to maintain the same standard across. So come to configuration tab, give my display name and my host name, and I am done with that particular part. All right. So now I have my computers connected there, and the next thing I need to do is now to connect. The cables are missing. The devices are placed on the table, but I have not yet used the cables. And this is one of the most important parts for us to understand the different transmission media and what kind of cables to use at a particular time. All right. Now, we have three major cables that we want to talk about. The copper straight through cable, which is usually this one you'll see here under connections. You'll see the copper straight through cable, and it is used whenever we are connecting different types of devices. Like for example, PC to a switch, laptop to a switch, switch to a router. We mostly use the copper straight through cable. The reasoning is simple, because if PCA and a switch have different types of devices, they transmit and receive data on different electrical wire pairs inside the cable. So straight through cable connects each pin directly on the same pin on the other end. You remember the network standards, because two different devices, different types, they transmit and they receive pairs naturally line up, because you have used straight through. What is on this end is what is also on the other end. Now, the other type of cable is a copper crossover. It's an Ethernet cable. And we mostly use this when we are connecting the same type of devices directly to each other. The common uses are, for example, if we are connecting a router to a router, like we want to connect this router 1 to this router there, we use it. Or we want to connect a switch to a switch, maybe the speakers switch to this, we use a straight through. Or a PC to a PC, PC0 to PC1, we use a crossover cable. When two different devices are connected, same, we are transmitting same pair. That's the reason why. And a crossover cable just helps to solve this by swapping that what we transmit and what we receive in pairs, right? So it connects 3-pin, pin 2 connects to pin 6 on the other end, so that one device can transmit and the other receives correctly. That's why they're there, and there are other different devices, so I want to look into them. The other cables that I want you to see, we have the fiber optic cable. You know what it does. I'll not talk about it. We have the phone cable. We have the serial DCE and serial DTE cable. So this cable is used when you are simulating long distance WAN connection between routers, such as maybe a leased internet service provider line. So one end is the DCE data communication equipment, which provides the time clocking signal, and the other end is usually the DTE cable. It requires a clock rate command to be configured, but we shall not get into that right now. So we are not going to use them for this particular tutorial, but I just wanted you to know what they are and what they do. All right. So we're going to connect all these cables, and we have these PCs. We're going to connect them. Speakers, computer. Which kind of cable are we connecting from PC0 to PC1? We are definitely going to use copper straight through. So you come here to connect a cable. Click on the cable you want to connect, click on the device, select the appropriate port, come to the device itself. In this case, I'm connecting to the speaker switch, and then select the appropriate interface. When you click on a switch or other devices like a router, they have more interfaces. So you find that this switch I've selected is having an interface all the way from 1 up to gigabit Ethernet 2, and so on and so forth. So in this case, sometimes it's important that you follow the network design. You look at what did the network require you. Which port? You look at the topology. If they have given you a topology, a picture with the interfaces, is it first Ethernet 01, 02, is it 4, is it 5? And then you connect. If they have not specified, then you are free to use any interface of your choice. But in this case, they specified and we must connect it to port 1, just like that. So you repeat the same process, select PC2, select the speaker, and then select interface 2 because it's what's available. We proceed and do the same here. Connect this one, connecting to 1 and 2, 1 and 2. This one also is connecting to 2, just like that. Simple, easy peasy. Select the interface, interface 1. Go to another computer, still interface 2. Come to this one, select that. Come to that one, select interface 1. Come to this one, versus Ethernet 2. And then you're good. All our computers are connected to our switches. Now we need to connect our switch to the router. Still, they are different devices, so we are going to use a copper straight through cable. And from our speakers, switch all the way to the speakers, this R1 router, they are going to connect via gigabit Ethernet 01. So for the speaker here, let's connect it to gigabit Ethernet 01. And then when we come to the R router, let's connect it to gigabit Ethernet 0. So you should always remember that. Here we have connected it to 0. Here we have connected it to 1. It depends on what you want to achieve or what your requirements are saying. I'll repeat the same here for the leader of opposition, gigabit Ethernet 1. And then I will go ahead to my router 1 and then I connect it to gigabit Ethernet 1. So I have it there. Repeat the same scenario. Come to my switch here, connect it to gigabit Ethernet 1. Here I'm going to connect it to 0. Repeat the same gigabit Ethernet 1. Here repeat it to gigabit Ethernet 1. So I have my switches connected to my routers. Now the other thing I need to do is to connect my router right here using my straight crossover cable because these devices are the same. So I'm going to come here, select this, and you can see the only port which is available is gigabit Ethernet 2. So I'll select that. Come here, select the only port which is available. So I have my gigabit Ethernet 2 ports available there and they are connected. Now you will see different types of colors lighting on your topology. You'll see, for example, here we have green lighting, here we have red lighting, and green basically means that the link is up and working correctly. When you have orange, those where you'll see orange, I'll show it to you when it comes. It means the link is initializing, no more startup. You can just wait a few seconds and then it will either turn green or red depending on what you have configured. But when you see red like this with these arrows pointing down, it means the link is down. Either you selected a wrong cable, wrong configuration, wrong port, or the interface is down. So you just need to find out what could be causing the red, and then you try and troubleshoot later on. Now, this is done, but we need to do certain things. We need to assign IP addresses, and we also need to do some basic configurations for our devices. For example, the switches are out of the box. They are new. By now, anyone who just connects to them can access them. They have no passwords. They have, okay, we have put the host name, but most of the times, all other settings are basic. So sometimes, as a network engineer, they may give you different requirements or different settings that you may configure. In an exam, you can only focus to what is being asked. In real life, you can do the basic setup and ensure that they are all catered for or taken care of. So here, we are going to, of course, configure our switches, and we need to understand that whenever we are configuring a switch, we have something we call the command line interface, the command line mode first. So before typing any command, you need to understand how the Cisco device organizes access into levels. Think of it like the levels you have access to. You are the student, you have the course leader, you have the GRC, you have the minister, you have the guild president. Then, so there are levels who can help you access different things depending on what you need to get from your university. So, also when we click, for example, on the speakers switch which you want to configure, and we come here into the command line terminal. This is what you'll see. It will be looking like this all the time whenever you access it. So what you do, you just hit enter. All right, let me first exit from here and exit. You just hit enter. By default, when you hit enter, it will look like that. Sometimes it will even be given the name, just switch, and you have not yet given it the host name. So your role here is to go ahead and enter into the privileged mode so that you can configure certain things. By default, you are into the user mode, right? The user exit mode is where you access the switch from. This is where you land, where you first open the command line. You have limited access, and there's nothing more you can do. On the other level now, the second level, which is we call the privileged mode. The privileged mode is used whenever you want to access different things and you want to do different things. To do that, you just use the word enable. You type in the word enable. In Cisco, you can write the full word or you can just write the shortcut if you know the shortcut. So en or enable, they will do the same thing. So I can just do enable and then hit enter. Once you see this hash sign, it means you have been granted permissions and now you can do other things. The next level now is the global configuration mode. From the privileged mode now to the global configuration mode, where you are in full control of whatever you want to do, and every configuration command is typed from, as long as you want to configure anything, whether interface, change what, as long as you want to configure anything, you need to first enter into the global configuration mode. And to do that, you can just type in the word configure terminal. But like I told you, if you don't have a lot of time, you can just say config T. It will still also work. So let me just write the full word, which is configure terminal, like that. And now you'll see config in brackets. So here you are able to configure the terminal and change different things. But also you can even go to another deeper level, higher level, where you have specific configuration, not for the entire switch, but maybe for an interface, like maybe SSH interface, or maybe the interface on the port itself, and you want to configure that link and you want to do whatever you want to do on it, right? Maybe you want it to take you to gigabit Ethernet. You can just go ahead and say interface, all right? And then the interface you want to go in, maybe gigabit Ethernet, you want to go into 0, 0, all right? And then you will enter into that gigabit Ethernet port that you want to access, all right? So it depends on what you want to access in that regard. Or maybe you want to access line console, right? So here is where you go ahead and access a particular interface. But when you're done, you can use exit to take us to the previous level, or you can use end to just jump out of that and take you directly all the way up to the privileged mode. Now, if you have not disabled the DNS lookup, you will see that every wrong command you type, your switch will try to translate it into domain. So we shall come to that later and see how can we discard that. So when you open the router or the switch for the first time, sometimes, and you go to command line, sometimes it may ask you whether you want to enable or you want to go into initial configurations. There is a question, do you want to go into initial configuration? Let me just put the router just for demonstration purposes here. For example, this one. So once I open this router here and I go to wait for it to power up, and I go to the command line and it has powered up and I want to enter, it will ask me, would you like to enter the initial configuration or not? So I can either choose to say yes or no, but best practice is you always type no, so that you can configure everything manually, what you understand. For example, here, you seeing this on the screen, it is asking me, would you like to enter the initial configuration? So here, just type no, and then you can be able to configure the router with the settings that you want yourself, all right? So let's continue now. We need to go into our switch and we want to set the host address. So if you are not set the host address, remember we said we need to first enter into the global configuration mode, and then to set the host name, we just say host name, the name was switch, and then it was speaker, like that. And then we have set our host name. Why does it matter? Because it will help us to identify which switch we are working on. So you repeat the same on the other switches as well, and you finish them up. To disable DNS lookup, so that when you type in a wrong command, it doesn't have to resolve. All you need to do, the command for disabling is no IP, and then you type in the word domain dash no space look up, right? No IP domain lookup is a command we use, and this stops the device from trying to look up a mistyped command as a website address or internet. Why it matters? Because without it, if you accidentally type in a wrong command, it will always look, and it takes like about 30 to 50 seconds depending on how fast your router or switch is. And sometimes it can be frustrating. Imagine an exam, you have typed in something wrong and it is loading forever, right? So best practice, just disable DNS, and that is the command we use for disabling DNS. Sometimes to avoid the people to access your devices, you can set a password, and to set a password for that device, we can say enable password, which is maybe BBC 26. That's what I'm going to use, right? But if you're an exam, put it in only if they have asked you to. If they have not, you'll lock out the examiner and they're unable to access your work. So enable, I think it's a spelling. Okay, I had misspelled the word password. So enable password. And if you type in a command and you get an error, please don't run mad or see. Just look at what you have done, correct it, type in the correct one. As long as you're seeing invalid input detected, just know there's something you're doing wrongly. Just correct it, and then you should be able to move on. So meaning whenever someone tries to access our privileged mode, now we have protected it with a password, which is BBC. So without this password, no one can try and access this particular switch to configure different things. But if you're using enable password, it means people can always access the configuration setup file and able to see which password you set. And to sort that, we can always use the one which encrypts the password, which is enable secret, and then we can use any of our choice. So now these moves will be stored in our configuration file, which is encrypted in that regard, right? So now, the other commands that we can set a password for the console, the line console command, and to do that, we can say, go ahead and we enter. Remember where I said we can go to a deeper level, so we can enter line console 0, all right? Now we are inside line console, and then we can give it a password, and then we can give it a password of moves, and then we ensure that we have enabled it for login, and then we can exit the console, right? So these are just the command. Enter the line console, give it a password, enable it on login, and then you can move away, right? So line console enters into that configuration console, and then only that console is configured with a number, 0 is configured with a password. And then we give it a password, and then we exit, and then we come back here. The same applies, we can also enable for VTY or SSH for remote access. To enable for VTY, what we do still, we go into line, this time around not console but VTY, and all these 5 interfaces, interface from 0 up to 4, we can go ahead and enter all those interfaces, and then we give them a password, and the password is moves, and then we enable it on login, and then we can now exit. So that is it. We have enabled the password for line VTY interface 0 to 4, which means that any device, Cisco device that supports all those 4 lines, they are configured to go through the sessions, and all 5 must get the same password. In this case, we have given them a same password, which is mobs, right? Why it matters? Because hackers will try to remotely log into your switch. They will try to remotely log into your router. So you need to safeguard it or protect it. Now, sometimes we need to set a banner. A banner is just like a welcome message, right? Or a message that is displayed whenever the switch is on standby or whenever someone tries to connect to that switch. How do we enable that? We just say banner MOTD, and then we use the hash symbol, and then inside that hash symbol, it is where we put our message. All right. So in this case, my message is going to be BBC is the best. And then I close with the hash symbol, just like that. So we put our message inside the hash symbol, and then we close the hash symbol. It will display the message. The hash symbol is the like something which tells the device that this is where the message starts and this is where the message runs, so that you are able to run other symbols inside your particular message. So if I hit enter, next time I try to access the switch, it will show me the message that BBC is the same, or is the best. So now, another important thing that we usually do sometimes is to ensure that we encrypt all passwords. And we do this by running the service password encryption, right? So the service password encryption is a command that we use to encrypt all plain text passwords inside our configuration file. And then that is it. So we have looked at enable secret, enable password, and all that is done. So when you're done with all your configurations, sometimes it's nice to copy the running configuration into the startup configuration. And you can do that by saying copy run, right? And then start, like that. Or sometimes you can say copy running configuration, copy running configuration to startup configuration. Or the shortcut is sometimes just say write. That one like that. It's a shortcut. Or just say RW. If you first exit here, let me exit here, and then I can say RW, and then it is building the configuration file, and then we are good. Or if you wanted to run it from there, you need to put the word do write, and then it is able to copy the running configuration from your RAM, and then it saves it in the non-volatile RAM. So next time when your switch starts, it will be powered up. So basically that's what we have done. We have done all the configurations you can ever think of. All right. So we can even come back later on to see if those configurations are there. So let me first exit. Right. So you see that next time I am coming, it is asking me for a password. I think it was BBC26. Right. This was mobs. Yeah. So the password was mobs. Now, when I say enable, it's asking me for a password, which was, I think, BBC26. As you put the passwords, ensure you put passwords you remember. Okay, so I used mobs. So I'm here. Now I have put in my password. I have accessed my device. So I can go ahead and say, show, why am I running show running configuration? I am show run. I can just say show run or show run configuration. The shortcut is show run, or you can type it as a whole, show run configuration. But I am running it inside the privileged mode. Reason being, I am not changing any configuration. If it was to do with changing configuration, I should have entered into the global configuration. Please remember that, and then you'll be good to go. So if I hit show running configuration, these are the running configuration. You'll see the version of the thingy, and then we hit enter to keep showing more. We can see that we set the password, we enabled password, no IP lookup, spanning tree, the interfaces which are up. If I hit enter, it just keeps on loading more and more of the configuration. The banner is there, which is a BBS is the best, no IP address, blah 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 blah. So whatever configuration we would have run is stored inside the running configuration. So every after configuration, please just ensure in the privileged mode, just run your command of copy running configuration, or just say write, and then it will write to the non-volatile. So you repeat the same configuration on this switch, on the other switch, and then you're good to go. So let me just I have my configuration already. So let me just come to my switch here, and then I'm going to paste it in, and then I'm good to go, right? So I have my configurations done. I'm going to repeat the same for the leader of opposition. I'll configure. After, by the way, when you're done, you can just copy. When you're done and you know they're going to be the same commands apart from the host's address, you can just copy everything in here. For example, when I come here and I say show run, I can come and copy the command there, and then I go and paste it there, right? So I'm going to come here to my configuration. So I'm going to come here, get my lop here, and then paste everything that I need, and I'm good to go. And then I'm going to come to my clock switch. We'll go ahead, command line, enter, and then paste everything that I need. And now I'm left with my router, right? So I need to configure the router. I'll open router 1. Same process, I can still give it the same thing, but I need to add some under. So I need to go ahead and enter some interface, like this interface of 001, and give it an IP address, and also another interface, and then give it an IP address, right? So let me first come here, do the basic configurations, maybe host name, what if you have not yet done. And now I'm interested in accessing interface jig 000, right? So I'm going to say config terminal, and then from config terminal I want to enter interface, this one here, right? This one, the one which connects to the speaker's chambers. It is jig, so I can write it the way I can see it, which is jig 0/0, like that, and then I hit enter. So I'm inside that interface. Once I'm inside that interface, I can go ahead and give it an IP address. Remember, when you go back to our resources, you realize that the different interfaces, they were able to give us the IP addresses to use. Now for that particular interface of that one, you'll see that they have given us the default gateway. So it's what I'm giving, what I'm going to give that interface to the speaker's chamber. This one here, they have given it to us, and sometimes they even tell you that this is the link that you use. So I'm going to come here and I'm going to add that IP address, and then this is usually the first valid IP address on that network, right? So IP address, which is 192.168.50, remember what we calculated, .1. The subnet mask here is 255.255.255.192. Let me explain something. Please pay attention. When you look at our address table we did together in VLSM, this table that we did together, let me just highlight this table that we did together here, right? You realize we have our subnet mask. We calculated this together, right? So don't ask me where this other subnet mask is coming from. Because of this prefix, we borrowed bits, and by borrowing bits, the subnet mask changed from the default one to this one now. And the first valid IP address is usually used as the gateway, right? So that's why we are assigning it to our router interface connecting to that network. And you can see it is what I used here. So that's why it is important, if you're given a number, to calculate things properly, because if you don't, you may end up also losing marks in other parts which are depending on your calculations from the previous number. I don't know if that is very clear and loud enough. So this IP address is what we are going to use as a gateway for this one. This is what we are going to use as a gateway for this network. This is what we are going to use as a gateway for this network. And this is what we are going to use as a gateway for that network. I hope that is clear. All right. So I will come back to my packet tracer file, and then I have put in the default gateway to that one, and then I'll go ahead and hit enter. But you realize on my topology, it is still showing a red arrow. Why is it showing a red arrow? Because the port status is down. So I can come back here, and then I use the no shut command here to ensure that it is up. So I can just say no shut, or I can say no shut down. And once I do that, you can even see that the link state here has changed. We have now some green and orange from red like these other ones. It has what? It has changed. All right. So that is the purpose of that. We have given it. So now we also need to do some static routing as well, so that it is able to know that we are sending this data from this network that is coming in from this network, the network of 96. Let me go back to the table here and show you. The network of 96, the leader of opposition here. The leader of opposition and the office of the clerk. So we need to have those two static routes. So we need to add those static routes, but for your case, we may come when these static routes are already provided, or when the command is already provided, and you just have to, sometimes it is done that way, and you just have to provide them depending on your action. But we are saying we need to have a static route for this and this, so that these people know that whenever we want to communicate to these guys, this is the static route that we need to take in that regard. All right. Sometimes it is known like that. So we need to configure them, and we put them in our network topology so that they are up and running. All right. So let me just come to my switch because of time. My router, first exit here and exit, and then paste in my commands at the same time to just make it easy. And we have all the links up and running. But I've just repeated the same, what I did up there, I repeated the same gateway for this particular interface. All right. So now I've put in the banner MOTT if they have asked you to do so. Sometimes they may not ask you to do that, depending on what you need to achieve. And I'll also repeat the same on this other router. However, you can even do it without going to the command line by coming to the configuration terminal. And I see that this interface 00 is what is connecting this one. So I'll come to the leader of opposition, and I say interface 00, make sure the port status is up, then come here and give it an IP address. What is the IP address for the leader of opposition? I come here, the default gateway. I come here, look at the leader of opposition. My default gateway is 97, isn't it? So I come to 97 on my table. I think how it is important to draw that table very well. And then also come to the subnet mask. My subnet mask is 240 here. So I'll come here to the 240, and then I'll type it in here. It is not that default. So I put in my 240, and we are good to go. I repeat the same for the interface, which is connecting to this other subnet, which is the subnet for 001. So I'll come here, look for 01, get it, ensure I have turned it up on, and then the IP address which was connecting that, the default gateway is 13. And if you come to our table again, just to emphasize this, you realize that the 13 is the first valid. It is here. We are not getting them from the blue. It is here. So I get it, and then I also get my subnet, which is .48. I copy it, come back to my configuration screen, and then I'll go ahead and paste it in. Once I'm done, good. So I have my link terminals there, and they're able to communicate with each other in that regard. All right. So basically, that's what we do, and you have your devices connected, and everything is up and running. Our links are up and available. So we have configured all those things. The other thing we are left now is just giving our computers IP addresses. How do we assign IP addresses? Easy. We come to the office of the speaker, network, come to our computer, click on desktop, come to IP configuration, and then from the IP configuration, we can come back to our table, and this table, for example, office of the speaker, it is saying that valid hosts range from 1 to .62. But remember, we have already given away 1, so 1 is not available. So meaning we can work from 2 all the way up to 62. So we can assign .2, we can assign .60, .59, all of those available. So let me just copy this, come here, and then it can be I can even start from .10, right? And then the subnet mask, you remember, it is no longer that, it is 192. The default gateway, you remember it, it is .1 for that particular network of the speaker, this one. So I come to the next one, come to the desktop, IP configuration, IP .what? I can give .11 because I already gave away .10. Our subnet mask was .92. All these things are in your table, right? You don't have to scratch. You just have to look at the table, which you did, and all these things are inside your table. So this is our default subnet mask. So our subnet mask is that, and the default gateway is .1, and then we can leave the DNS server. So these two computers they should be able to talk and communicate with each other because they're on the same network, and you can see we have successful, right? Now, same applies to the government chief whip network. So we go back to our table, we look at the IP addresses we can assign. Chief whip, the network is this one, that is a network address, but the network starts from 65. But remember, 65 we gave it as a gateway interface on our router. So meaning we can start from 66 all the way up to 94 because we can't assign the broadcasts. So we can start from 66 all the way up to 94. So I can do maybe 70 and 71 in this regard, isn't it? Now, I'm going to come here. Let me just copy this and come to my PC here, desktop, IP configuration, and then give it an IP address. We said we can start from 66, and then this was 224, and then the default gateway was 65. You remember? Repeat the same for this, which will be 66 in that regard. So come to this desktop, and then this was 66. We gave it away, so we can do 67. The gateway was 224, and then the default gateway was 65, and we are good to go. So you'd repeat the same for all other PCs. Now, without the router, these two computers would never be able to communicate with these speakers because they're in different network. But because there's a router in between, we can test by sending our message from this one to this one. The first one will of course fail, but the moment we keep sending, the second one, must be successful. The second or third must be successful. The first one fails because the network is learning, right? Learning about the topology and everything. So now, this is basically how we configure everything that we need as network engineers. And to save our work, all we need to do is we can just come and save file, and then we say save as, and then after save as, we go ahead and give it a name. We give it a name which you want to give it. In this case, maybe I can go to the desktop and ensure that it is inside my folder. Maybe this is my folder CN, and then I can give it whatever name. If they've asked me my name, I give it my name. Ensure I follow the instructions given to me, and then I go ahead and press on save. Now, sometimes they may give you a file which is pre-configured, so they expect you to open that file and you work from that file, so you don't create your own file. Please just take note of that. But basically, this is our simple basic configuration, and we have been able to look at that in that regard. So what we have done, we have looked at the commands that we need, we have looked at the configurations. So it's important that you pay attention to some of the things that discussed if you want to be a good network engineer. So thank you so much for listening to me, and have yourself a good time.